Hello everyone, and thank you for being here. My name is Dilhabid Mkawi, and it is my pleasure to present this work conducted in collaboration with Professor Hajim Youssef. Our study is entitled Multi-Touch Attribution in Marketing, Comparing Patents and Academic Advances. Before we begin, let me briefly outline today's presentation. I will start by explaining the motivation behind our work and why multi-touch attribution, or MTA, is so important in the current marketing environment. I will then compare the trajectories of academic research and patented industry innovations, highlighting their distinct priorities. After that, I will describe the methodology we use to build our comparative corpus and summarize the main findings from this analysis. We'll present our proposed multi-touch attribution optimization framework, or MTAOF, which brings together the strengths of both academia and industry. Finally, I will discuss limitations, future research directions, and conclude with the key contributions of our study. The question we address in MTA research is fundamental. When a company invests in digital advertising, how do we know whether it worked and which marketing channels actually contributed to the outcome? For years, this question has been surprisingly difficult to answer in a rigorous and reliable way. The importance of the problem is evident when we consider the scale of global digital advertising expenditure, which exceeds 700 billion US dollars annually. Each of those dollars represents a decision, and behind every decision lies the question of how to measure marketing impact and assign credit fairly across multiple channels. Historically, the industry relied heavily on last touch attribution, where the final click or interaction before a purchase receives 100% of the credit. While this method is simple and computationally efficient, it introduces a severe bias. It inflates the roles of closing channels while ignoring earlier touchpoints that create awareness and consideration. As several authors, such as Anderson and Chang, have shown, this leads to distorted views of customer journeys and can result in suboptimal resource allocation. The limitations of last touch attribution gave rise to the field of MTA, which attempts to capture the joint contributions of multiple marketing channels. However, the field has since diverged along two trajectories. On one side, academia has pursued theoretical rigor with a strong emphasis on causal inference, fairness in credit allocation, and methodological innovation. On the other side, industry has prioritized scalability, speed, and integration into large-scale analytics systems. These are, in a sense, parallel worlds attempting to solve the same fundamental problem. We can observe this divergence in the temporal evolution of contributions. During the early 2010s, academic research in multi-touch attribution expanded rapidly, peaking around 2016, with methods ranging from Bayesian hierarchical models to game-theoretic approaches, such as Shapley value decompositions. However, as academic publications stabilized, we witnessed a surge in patent filings from major technology firms after 2020, peaking in 2022. This suggests that once academic research clarified methodological best practices, industry translated these into deployable products. The main actors in the industrial push are, no surprise, companies such as Adobe, Google, Microsoft, and Salesforce dominate the patent landscape, alongside contributions from Amazon and independent innovators. Each seeks to integrate attribution into its broader ecosystem of marketing and analytics solutions. The comparison between academic research and industry patents can be summarized clearly. Academic goals is causal accuracy and methodological refinement. often employing advanced models to capture user heterogeneity, carryover effects, and incrementality. Industry, by contrast, focuses on speed and scale, leveraging simpler allocation rules or scalable adaptations of game theoretic methods to process massive, high dimensional datasets in real time. Our research set out to systematically analyze these two worlds. We began with a corpus of over 200 works, consisting of both patents and academic studies, applying strict inclusion criteria based on relevance and methodological substance. We identified a final set of 62 academic articles and 53 patents. This dual dataset allowed us to compare not only the goal but also the methods, validation approaches, and practical outcomes across academia and industry. The result of this analysis was not only descriptive but also synthetic. It allowed us to propose a new conceptual model that bridges the gap between the two approaches. We call this the Multi-Touch Attribution Optimization Framework, MTAOF. The framework is structured into 5 layers. The first layer concerns data collection and integration, bringing together customer journey data from multiple online and offline channels while addressing issues of cross-device tracking and data quality. The second layer involves method selection, where the system automatically chooses the most appropriate attribution model depending on the business context and data characteristics. The third layer, which we call smart optimization, seeks to balance 3 competing goals: accuracy, computational efficiency, and interpretability. The fourth layer emphasizes validation and testing, combining academic standards of statistical rigor with business-oriented measures such as ROI improvements. Finally, the fifth layer provides decision support, translating model output into actionable insights through dashboards and scenario planning tools that marketing managers can actually use. What distinguishes this framework is its ability to integrate the strengths of both domains. From academia, it inherits methodological rigor and fairness. From industry, it incorporates scalability and practical deployment. Of course, we also acknowledge the challenges that remain. Data coverage is still incomplete, causal inference is difficult to establish robustly, and privacy regulations are increasingly constraining the collection and use of individual-level data. These issues represent significant obstacles, but they also highlight important avenues for future research, such as the deployment of interpretable deep learning approaches, standardized causal testing protocols, and privacy-preserving attribution methods through blockchain, for example. To conclude, our contribution is twofold. First, we provide a systematic synthesis of academic and industrial advances in multi-touch attribution. And second, we introduce the MTAOF framework, which offers a structured pathway to integrate academic rigor with industrial scalability. Finally, the challenge for the future is not merely one measurement, but of strategy. As attribution models improve, marketing itself will need to evolve, guided by a more comprehensive understanding of the customer journey. This evolution has the potential to reshape a multi-hundred billion dollar industry. Thank you very much for your attention. I look forward to your questions and discussion.